is this a monotonic sequence? Let's find out. To evaluate the values of sine, I would like to use radian mode. Okay, let's write down radian mode. Okay, when n is equals to 0, okay, n can be equal to 0, I have a sine 0 times pi over 6, so 0 pi over 6, that is equals to sine of 0. Sine of 0, that is equals to 0. And then a1, that is sine of 1 pi over 6. Sine of pi over 6, that is a 1 half equals to 0 0.5. And then a2, that is a sine of 2 pi over 6, that is sine of pi over 3 is a root 3 over 2, that is equals to 0 0.866. 0. And then a3, that is a sine 3 pi over 6, which is a sine of pi over 2, that is equals to 1. So far we go from 0 to 1, that is increasing. Is that always keep increasing? Let's find out. a4, that is a sine of 4 pi over 6. Okay, this one, if you use your calculator to evaluate that, that is a 0.8660. 0.8660, just like a root 3 over 2. Okay, it looks like from here to here, we have an increasing. And then starting from the other side, we will have a decreasing. Can I put this in here? And then move this one down? Yes, just move this one down. Yep. And then a5, that is a sine 5 pi over 6. 5 pi over 6, that is equals to 1 half a6, that is a sine 6 pi over 6. Sine of pi is equals to 0. And then a7, that is a sine 7 pi over 6, that is equals to negative 0 0.5. Okay, we go from 0 to 1, and then from 1 back to a 0, and then looks like we are keep decreasing, right? So from 1 back to this 0, so we have a decreasing, and then we are keep decreasing. Are we going to go back up again? And then n equals to 8, sine of 8 pi over 6. 8 pi over 6, 7. Oh, I didn't try 8 pi over 6 on my notes. Okay, let's see. a4, I'm checking this with my notes. a5, 1 half, a6, 0, a7, negative 0 0.5. No, I didn't try 8. I tried 9. Okay, then I will just follow what I wrote on my notes, 9. And this is a 9 pi over 6, that is equals to negative 1. So it looks like we are back to a decreasing again. So we go from 0 to 1 increasing, and then we are keep decreasing. So this one monotonic is either increasing constantly or decreasing constantly. So if you mix up the increase and decrease, then this is not monotonic. Not monotonic. Monotonic. And then what happened as n goes to infinity? So this one as n goes to infinity, so limit as n goes to infinity, I have a sine of n pi over 6r. This one you can use a squeeze theorem. This one you can use a squeeze theorem. It cannot this one for the sine of n pi over 6. So as n approaches to infinity, that is just bouncing between negative 1 and 1. That is a bouncing between negative 1 and 1. So this cannot be determined, but I can tell you that negative 1 and 1, this is what the sine of n pi over 6 between. So sine of n pi over 6, that is between negative 1 and 1. So that means using a graph, we will have this. That is a y-axis, x-axis, and then we have an upper bound at 1, and then a lower bound at negative 1. And then we will just have something that bounce up and down like this. Starting bounce up and down and then up and down. So this is not bounded. This is not monotonic and this is not bounded. You know what? It's between -1 and 1. Okay, you know what? I will just take this back. Not bounded. I will say this is bounded. Between -1 and 1. You cannot say not bounded. It's bounded between 1 and 1. The 1 is the upper bound. The -1 is the lower bound. So it's bouncing between 1 and -1. Yep. So not monotonic, bounded between -1 and 1. All right, so that is the end of this video. So this video, I did a sine. Okay, how about this? In the next video, I will do a cosine. I will see you all in that video.